Meteorologist Tuttle here. For years, I've been recommending Ferguson Roof Systems to homeowners across Oklahoma. So when Mother Nature struck my house, it was an easy call to make. There's no one I would trust more than Ferguson Roof Systems for my home's roof. Since 1977, Ferguson has led the industry with an A+ Better Business Bureau rating and lifetime warranties. Plus, they'll even deal with the insurance companies so you don't have to. So when Mother Nature strikes, make your first call to Ferguson Roof Systems.
Hey there, Meteorologist Tuttle. It is Tuesday. Is it Tuesday? It is Tuesday. We're going to talk about the latest with the winter storm that is still developing out to our west. That'll be coming our way as we head into Thursday and lingering on Friday morning as that moves on out. We'll see how much snow falls, who's going to get the snow, who's going to get any ice, who's going to get any rain, who's going to be happy, who's going to be sad, all that stuff. So thanks for tuning in here on Instagram Live, also on TikTok Live, also on YouTube Live, Rumble Live, Twitter X Live, and of course Facebook Live. So good to have you guys here. Thanks for liking, sharing the post, the feed, your support, hitting the subscribe button, whatever you want to do. Knock it out. All right, let's take a look at what is currently on the docket. Now out there, we still have a cold night. I was outside working in the garage and man, it was chilly. Too cold for my sake. I'm at 23 degrees. It'd be nice to warm things up, right? If we do look at temperatures elsewhere, well, we're in the 20s. I got some teens up north. Let's see, the coldest spot looks like Medford, Oklahoma, Newkirk about 16, Blackwell 18. Otherwise, another cold night ahead. If you look this morning, we had some cold temperatures again. We had single digits up here around the northern counties of Oklahoma, into the teens elsewhere across the body of the state. Are you tired of it yet? If we look at temperatures this afternoon, they warmed up above freezing if you lived in a western and far southern Oklahoma. And then if you kind of lived in northern Oklahoma, you didn't really get that much warmer. You still stayed into the 20s up in this little sweet spot here in north central parts of the state. So unfortunately, you did not get in any of the good action there with the sunshine that came out to get you above freezing. And we barely got above freezing in here in central Oklahoma, just by a hair in some areas. So, you know, it is what it is, but we do have some changes coming our way. Part of the changes are going to include how warm our soil temperatures, and they're into the 40s in North Texas, into the 30s here in Oklahoma, which is kind of important, especially when we have a situation where the storm system is going to be barely cold enough to produce snowfall. So if it gets too warm, obviously that stuff melts quite a bit. Now out there currently, the National Weather Service has issued a winter storm watch. It's this little area here you see in blue on the legend. So the blue area continues across southeastern, let's say 1/3 of Oklahoma, on into North Texas, including Dallas-Fort Worth, out to the east from there toward Tyler, Shreveport, Texarkana, back over to most of Arkansas, and then a sliver of looks like Louisiana on into Tennessee and eastbound. All right, let's take a look now what we've got in the upper levels. So this is the NAM model looking at the latest data that came in. Again, we're watching our storm system form out here to the west. You said big curling, spiraling motion. Out ahead of it by Thursday morning, rather, you are going to see this little enhancement in the jet stream pattern here at 500 millibars. This is all the lift that is coming out and ahead of the main shortwave trough axis. That is what's going to help to generate the precipitation. As we go through the day on Friday, a lot of that does move across Oklahoma as well, so it is an Oklahoma southward event. Still some lingering action out here to our west. The system did not come across in one piece. The first piece sheared out with the second piece coming in behind it. Let's see, so that's Thursday evening. See how energy still rolling on through. And there's a big, long trough axis right here. Now, just a heads up for you, for meteorology's sake, I'm going to use this blue line here to designate the trough axis. So it looks like this, okay? So just so you know, if you do look at a 500 millibar chart and you want to find out where the lift in the atmosphere is, it is going to be on the east of the trough axis. So in this particular case, your lift in general terms is going to be in this quadrant here, back out in here. Now, it is going to be heavier in this area than it will be down in this area of Texas, but still some lift. So there'll be some lingering light precipitation here until this trough axis kicks through during the day on Friday. But most of our bulk of our activity will be on Thursday into Thursday night. All right, then that thing will move on out, as we said, and then things kind of quiet down temporarily. We do have some more upper level energy that'll be coming in off the Rockies. We're kind of an active storm pattern, plus the jet stream kind of buckles and does this little notch right here. So this allows that colder air to continue to spill down as surface high pressures come in across the central plains and also across the northeast. So the cold pattern will continue for at least the short term. All right, let's take a look here at the below that level at 700 millibars, where we see the red and the yellow. We can start the precipitation developing. So this is about 3 o'clock in the morning on Thursday. So we should start to see some virga and light precipitation breaking out here, especially making it to the ground probably in this area, still evaporating before hitting the ground into central Oklahoma. And the reason why I can show you that is if we do look at a forecast sounding, at that point in time, you see how these the green and the red are too far apart. That's the temperature and dew point. So when the atmosphere is saturated, the two of them will meet together. When they're this far apart, that means there's a lot of dry air in between. Down here in Texas, we'll go west central Texas. So you see here, it's quite a bit more moist at 500 millibars, so the mid-levels of the atmosphere has already moistened up by this point, but it still has some evaporation to go in this area of the atmosphere where these two are too far apart. So in the overnight period, Wednesday night into Thursday morning, the atmosphere will spend a lot of its energy and its moisture moistening up the atmosphere versus accumulating precipitation at the ground level. But as we head toward daybreak and onward, you do see the red areas intensify. That means a lot stronger lift during the middle part of the morning on Thursday. That moves in Oklahoma and also North Texas, you can see, Central Texas as well. And that continues during the midday hours on Thursday, and then Friday evening, another big blossom here of some heavy precipitation signature with the lift in the atmosphere. And we go into the evening hours by midnight. Things kind of quieting down here in Oklahoma. Still some stuff going on here across the eastern third of Texas as that system kind of still hangs in there through the Friday morning time frame. And then as you can see, as we go into Friday around lunchtime, most of that lift is pretty much now east of us as that trough axis shifts to our east. And then it takes all the precipitation along with it. So that's how you can kind of time things. You can use the 700 millibar chart at the vertical velocity level to get you an idea on time of when precipitation will start just based off the extreme lift. All right, if we do look at the relative humidity, in other words, in the atmosphere at 700 millibars, we do want to make sure we see some greens and blues on the map, and we do. This is Thursday morning, so there is a lot of moisture here to work with, so that is good news. That we do have that component in the atmosphere, so we have the lift, we have the moisture, so obviously we have a trigger to get some stuff going. Now, really, all that matters is the thermodynamic temperature profile. How does that look? But during the day on Thursday and the Thursday evening, you can see how the moisture continues to move through. By Friday morning, the big bulk of the heavy moisture is moving out. We're starting to dry out a little bit as these color contours change into a lighter shade of green and a lighter shade of pale. For my oldies. Up here across the body of Oklahoma as dry air filters in behind it. And then into Friday night. So that's kind of how that works. And yes, we always talk about the dry slot because somebody's going to get it. If you don't know what a dry slot is, it's a really way to damper your excitement when it comes to snow. Let's find out where it is in this latest model run. All right, so here's Thursday morning. Big batch of moisture right here moving through. Okay, that's good. Midday morning hours to lunchtime. Okay, see this right here? See what this is? That's a dry slot. It's trying to nose up in here. Let's see what happens. Just a little sliver comes in. Looks like mid-afternoon on Thursday, so that's not all that impressive. It does kind of solidify, though, in this little track right here. A nice little burst, though, of snow up across central northern Oklahoma as a result, and it keeps the snow here on the north side of Dallas-Fort Worth in a southeast Oklahoma. It's a nice little burst there, some heavy moisture. So in between, there's that dry air, which has a tendency to shut down the heavier rounds of snowfall and or other precipitation types and reduce the accumulation factor. So keep this in mind. If this were to verify completely and not move around, what this model suggests is that when you do measure the snow at the end of the day and or whatever else you get, you're going to have a higher amounts in this region and you're going to have higher amounts in this region, and in between is where you're going to have lighter amounts. So that's kind of how you would interpret that. Okay, so let's move on to, let's get past that. Let's do this one. Okay, so temperatures. This is the tricky part. So at the surface, we talked about this last night. This is a wet bulb event. So let's get you on into Thursday morning. All right, there's 3, 4, 5, 6 o'clock in the morning. All right, so our temperatures down here in North Texas are holding right around between 31 to maybe 34 degrees down around Cleburne. If we head on into the mid-morning hours and that precipitation starts to fall and starts to reach the ground, it prevents temperatures from warming up. So they kind of hold here into the lower 30s. And then we'll see if they drop some. They do. Plano drops at 31 by 10 a.m. Kind of holds around freezing at 32. Dallas 34. Weatherford 32. And you can see this little batch. Basically, where you see the blue is where you see temperatures that are at or below freezing. So little patchy areas, pockets here and there. Otherwise, kind of in the low 30s. Now, yes, you can get snow when temperatures are into the low to mid 30s. So that's not necessarily a problem here in this case. But the good news is, though, and this is what I have kind of fought with on the back of my head with the model data. The models have loved this idea right in here of a pretty good line of freezing rain accumulations. And it's hard to do that when you have temperatures that are with the dew point of 32 and a surface temperature of 34. So I'm thinking that the icing event that the models have been calling for is a little overdone. I think some light icing probability, maybe some bridges and overpasses, but I'm really not seeing the heavy accumulating ice just because the temperature profile here at the surface just doesn't really support it. The way things look in the current model data, if that changes, well, it's going to be a pretty dramatic change as we're getting closer to the event. Regardless, as we head to Thursday evening, still temperatures holding into the low to mid 30s here in North Texas. Now, it also does mean you can get some rain mixed in with the snow, and the snow that does fall will have a tendency to melt when you are that warm, faster than it would, obviously, if you were 32, so keep that in mind. It makes snow to beat the band, but if it melts as fast as it's what good is it? That's my problem. All right, let's take a look at Oklahoma. All right, let's go on into, by the way, let's just go look at tonight real quick. We were already, of course, low 20s, and looks like the models keep us low 20s. I have a dew point of 11, so I think that'll be a bust. I think it'll be obviously colder than what this is suggesting. I think it'll be upper teens again. Let's see here. I mean, it does have some colder numbers up here in Ponca City in the morning, 8 degrees there, but I would assume that some of this colder spillage will be down here to this region here in central Oklahoma as well. Otherwise, low 20s elsewhere with the body of the state. So another chilly start to Wednesday. And then in the afternoon, we're going to warm you back up to around at or above freezing across central, western, southern Oklahoma. Still northeast Oklahoma in the deep freeze. Tulsa probably not getting above freezing. All right, and then we'll go into Thursday morning. Right here, 6 a.m., 7 a.m. We're all below freezing at this point, pretty much for the state. We do try to warm things up for you. Look at that little patch of warmth. Looks like low mid 30s for midday Thursday across northern Oklahoma. A little colder spill moves back in. This is typically indicative when you see this pattern that moves in from a southwest to northeast of a cold pool. It just means that's a precipitation-derived cold pool, meaning top down, so that the cold air comes from aloft and gets brought down to the surface as that snow falls. So it's a good indication you'll have a nice batch of snow that moves through Oklahoma with that on the temperature profile. And that's about it. All right. Obviously, we're going to have some wind chills, even though the winds won't be that strong earlier on. Any breeze at all, is going to make an effect of that. So wind chills in the single digits and teens in the morning across the state. And tomorrow, not as bad. Again, they'll be light and variable, so it looks like 20s and 30s, which is close to the actual air temperature. And then we'll repeat again for Thursday morning. Wind chills teens and 20s, and then during the day, looks like probably still staying mostly in the 20s because we will have the wind pick up on Thursday a little bit during the day, and that's about it. Okay, so still the same, dress warm. Okay, let's take a look at the snowfall amount. So it has backed off of the significant heavier snows for the first part of the event for Wednesday out here in the Panhandle area because the storm system took a dive to the west-southwest of what it originally was going to. So if it moves a couple hundred miles, west, well, that takes everything with it, and then it changes the dynamics. So you don't get as much snow as a result out here at the beginning of the event. Now, so we head on into Thursday, though. We're still expecting that energy to kick through and the lift along with it. So that will move through into the Thursday morning time frame. So you can start to see the precipitation breakout here in western, southwestern Texas, starting to affect areas just north and west of Dallas at daybreak. That does quickly move in, though, in the metro. Now you see the colors. See how that's purple down here? So purple is an indicator of sleet in the model data, at least in this particular one. Temperature of 32, dew point 22, so we're still trying to saturate the atmosphere. So while it's a little drier at the lower levels at the beginning of an event, that's a favored profile for sleet a lot of times. Now this model, forecast sounding, says freezing rain, but again, I think it's more of a sleet profile. We will also, if you notice, this is the 0 degree line Celsius, aka 32 degrees. Remember, if your temperature profile is to the right of that line, that means it's above freezing. So if it's above freezing, it means it melts. So it snows all here, and then it melts here, and then it comes back here on the left of the freezing line, and it's back to freezing again. So that's kind of how that goes. It goes frozen, thawed, frozen. And when that happens, you get a mixed bag of precipitation. You can get rain with that. You can get snow with that. You can get sleet with that. Sometimes freezing rain with that. So it's a mixed bag here in North Texas. So you call it a basically mix of winter precipitation. All right, so on the mid-morning on Thursday, you can see how that now starts to saturate up here into the Oklahoma City metro area, points southward. But we are also just barely tiptoeing along that freezing line. So we might also, at the very beginning of this event, have just a little light mix before it quickly changes over into all snow, and that's a little bit different in the data than it was in prior runs where we didn't have any of that mix in there, where the atmosphere was pretty much cold throughout. This time around, the models are saying, we might have a little warm nose in there that gets us initially before the precipitation comes down in earnest. All right, but otherwise, you can see a lot of blue on the map for Oklahoma on Thursday midday. That moves up to the north. Remember that lift in the atmosphere I talked about earlier to start the program, and how temperatures would accommodate and cool back down with that precipitation breaking out. Now, here's the kicker. This particular model has a warm bias down here across Dallas-Fort Worth I-20 corridor running east and west. You see what this green is? Green's for rain. Green is not freezing rain. Green is not snow. Green is not sleet. Green is just plain old cold rain at 35 degrees with a dew point of 32. It does have a nice warm nose right here, which is above freezing, and it does try to get you back below freezing, but barely, by the skin of its teeth, and it may not be enough to solidify it before it has a chance to melt again before hitting the ground. So that means you can go back and forth in this deal. The model won't be able to tell. It's too close of a call, and the model will not have that type of fidelity in the resolution. Unfortunately, we just don't have that ability, believe it or not. I do believe in the future, short-term future, we'll have a drone network that will be able to change that. So 5 years from now, I think all that'll change, maybe 10 years at most. And we'll have a lot better forecasting ability in the model data when it comes to stuff like this, thanks to those drone networks. But for right now, that's in development. All right, so anyway, so here's Thursday evening. Again, that wintry mix looks like sneaking up here across the northern counties of Texas. Otherwise, all snow looks like for Oklahoma and Arkansas. So again, Arkansas, you guys can get a lot of good snow with this one. Even Missouri getting a little bit of a taste after you had your last storm system. Still some flurries and light snow out in this area too for Thursday evening. And southern Arkansas, a little bit of a mix as well. As we head to Thursday night and Friday morning, everything starts to move off to the east. Now it blossoms. Heavier precipitation develops into this region than it did in this region. Okay, so as the storm system kicks out, because of the way it's coming out and the way it's oriented, you will have better lift, better moisture east of Oklahoma and in Texas, which means you'll probably end up getting better, higher, more substantial precipitation amounts in this region when it comes to snow. So if you guys out here in Arkansas, up toward Memphis, etc., you guys can jump up and down, enjoy. All right, let's take a look close-up view, Oklahoma. Okay, so here is our time frame right here. At 9 o'clock in the morning, we should have some light echoes showing up on radar and some light stuff starting to hit the ground. So initially with this, it's bridges and overpasses, and then as it starts to get heavier, then roadways will deteriorate. Here's lunchtime. So it does have some light snow breaking out here in Oklahoma City, for example, by lunch on Thursday, and also in Tulsa as well, up in northern and eastern Oklahoma. Here's 5 o'clock, still some light, moderate snow across parts of Oklahoma, especially the eastern half of the state. So pretty good little storm snow system for us. We'll look at snowfall totals here in just 2 shakes. Let me zip down real quick, and I'll give you a close-up view of the Dallas-Fort Worth area and the timeline for that one, just based off of this model alone. There are several models that I can pick from, but I don't want to go on too long tonight. We can look at ones when I kind of got it wrapped up. But here's your 9 o'clock in the morning, for example. So here's 7, 8, 9. You can see how it blossoms and moves through. There's that wintry mix when you see all the different colors. Let's see. Let's go through 1 o'clock, 2 o'clock, 3, much heavier precipitation here. But it starts to warm you up. It says, hey, maybe you got more rain than you do anything else. Look at all that heavier rain. You don't want that, do you? Snow, though, just north of you, say from around Plano up toward Denton, Sherman, Denison, back up toward Paris, Texarkana, and points north and east from there. And then you can see you can see how the transition is. You see that blue sneaking back in here? That's the model having a tough time with the thermodynamic temperature profile as to whether or not to keep you all rain or to keep you a mix of rain and snow. That's a nightmare to forecast, just so you know. All right, so Ben, the bulk of the precipitation, this is just rain. In other words, if none of this froze and it was just all liquid, just all rainfall, this is how much rain you're going to get. And I'll just zip through the models to kind of show you the bullseye and the take home, in other words, what the trend is. So if you look at the gradient, what you're going to focus on is the gradient increases once you go from northwest Oklahoma to southeast Oklahoma, and then once you get to around Dallas-Fort Worth and then south and east from there, your gradient increases down to Houston. So let's see, that's the European AI, that's the European straight, Canadian, American AI, some of the other CAM models, the German model, NAM, blend of the models, Canadian, UK map. So there you go. So some decent rain, decent precipitation, regardless of what form it's going to be in. For what otherwise is usually a drier winter. All right, here's a look at the NAM when it comes to the ice, and I think a lot of this is going to be probably sleet accumulations that's mixed into this model versus say freezing rain accumulations. But it does have kind of a highlighted point where it mixes in on that southern edge of the snow right across Dallas-Fort Worth, sneaks on up here to Texarkana and Shreveport, back into say around Waco, and the hill country to Austin, etc. So that's probably where that would be. And of course, it does extend eastbound here to southern parts of Arkansas toward Memphis. All right, now we talk about snowfall. Here it is. Let's see what happens. So this is the latest time frame from each of the models that have run either from this afternoon or that have come in this evening. So this is the European model. All right, it is still going balls to the wall. It says I want it all. And so it's going 10 inches of snow in Dallas, 8 inches in Plano, 6 inches Sherman, Paris, etc. Nice little batch here, close to a foot in this little thin stretch. If we look at the American model, it's also it's a flip-flopper. In other words, it's one day it's bone dry, the next day it's Armageddon, the next day it's half steps it, the next day it's decent. It's the typical GFS flip-flopper. Anyway, it's got about 8 inches of snow here in Dallas, so it's at least in line today with the European. The Icon model, the German model, you can see where that gradient starts to sneak in around I-20. Remember we mentioned that before. So that seems to be a hard cutoff line in the sand, north and east of that, looking good as far as decent snowfall amounts. The NAM model, which is all over the place, and it flip-flops worse than the GFS, cannot be trusted, but just for giggles, this is what it's doing. If you look at the UK Met, it says forget it. It's not even an event. It's all cold rain. Suck it up, buttercup. If you were to look at the blend of the models, this is a very conservative approach, but it does take a more realistic, I think, approach as far as temperature profile goes to at least get you some measurable precipitation when it comes to snowfall. And at the bare minimum, it's got 1 to 2 inches here across Dallas-Fort Worth, much higher amounts once you get up along the border into Oklahoma, and of course, southeast Oklahoma and most of Arkansas. Now, this pattern, in other words, the way it's laid out, I like it. In other words, the contouring of where it starts, where it finishes, from low to high. What I do not like necessarily are the numbers. I actually think the numbers will be higher than this, as long as that rain doesn't hose me. I do believe the potential is there for higher than this, back to like the 5-6 inches of snow here in the greater Dallas-Fort Worth area. Higher amounts north side of town versus the south side of town. So that's the way it looks right now with that. Let's take a look at Oklahoma. Same idea. Now the European likes the I-44 corridor as the hard line in the sand for measurable snowfall. Higher amounts down in southeast. Here's the American model. Also same idea, but better amounts, 2 to 3 inches. The German model splits the difference. It hikes a secondary wave that sneaks on into this fashion, which is a different trend. Otherwise, again, southeast Oklahoma seems to be a good bet there. Here's the NAM for what it's worth. It just shoves everything north. Remember the dry slot we talked about? That was kind of coming into this area on the NAM. Remember that in the data I showed you? That's where that reference is. So if that were to verify completely, in other words, if it was 100% accurate, wasn't garbage data, That's how you can see the difference in measurable snow. That dry slide can hose you. So this is an example of what can happen with a dry slide. Now, will that happen? Maybe, maybe not. You know, it's a tough call. The model flip-flops so much. The UK Met, it also likes lower snowfall amounts because it's got different physics and not the best when it comes to winter storm in general. Sometimes it does get it right. We'll see what happens with this one. We'll see what the trend does. And then there's the blended models, which again loves the hard line in the sand for I-44, and then points south and east. So like I said, in North Texas, I like the trend on this from the look of it. As far as placement goes, although I just don't like the numbers. So for example, I like 1 to 3 inches here, with 1 inch, pockets of 2, you know, in this area. I've got no problem with that. But otherwise, 1 to 3 along the I-44 corridor. And then you're looking at, as long as there's no dry slot action, you're looking at gradual increase in snowfall totals as you get down into here, when you're looking probably anywhere from, you know, 7, 8 inches of snow when you get to the sweet spot of where the bulk of it will be. That's just my take on it. If you look at the European, for Oklahoma City, for example, that's all of its ensemble runs. Again, there's 50 of them that run here. So just one run of the European, they run at 50 different times. They nudge it different directions, and then they say, okay, what does the model kick out when you do that? And it does like 2 inches. So it's a good conservative, right in the middle ballpark number. I will show you that to kind of give you an idea what this looks like. When we talk about those ensembles and we talk about the different runs of the model, I'll show you what this is the European, for example. I'm going to show you the snowfall totals. All right, so this is your snowfall amount table here on the left. So 2, 3, 4, 5, 6 in blue, and then 6, 8 is yellow. All right, and you see the placement, the heavier placement of this, obviously. All right, so that's what happens. That's one run. That's another run. See how it shifts to the west and southwest? Here's another run back to the east and north. There's a run. Here's a run. Here's a run. Now remember, this is the same model, just nudged just a little bit in the variables. All right, there's another one, another one. So your take home here is that it does favor Arkansas, and it favors southeast Oklahoma, and it still favors North Texas. Everything else moves around a lot, both in distance and also in intensity as far as coverage. But as I go through each one of these, you can see how everything changes just slightly. All right, and which one is right? Now, of all of these, only one can be right. So which one is it? I don't know. That's just one model, one run of the same model. Let's go to the GFS. Same idea. Here's one there. There's one. Oh, look at that. No snow at all in Oklahoma or Texas. Okay, and that one flip-flops back to snow. So here again, just kind of give you an idea how this looks. So remember, you're a forecaster. This is the data you get access to, and you got to make heads or tails of all this stuff, right? And then be right 100%. All right, so here's the SREF, which is a good high-resolution model. Again, I like the breakdown. Oops, where'd it go? Put that back on here. I like the breakdown kind of where it has the intensity part. I just don't necessarily like the amounts. Let's see, here's the Canadian. The Canadian's been a wild child with this stuff. It's been moving it around as well, just like the rest of them do. Can't decide where it wants to put the big stuff. I mean, look at this one. It's got almost, let me go back over here. Can this one stay there? Yeah. It's got almost nothing here, which is where all the other models say all the other action is going to be, and it's got everything up here. It's just nonsense. And this is within 24 to 36 hours out from an event. So I'm telling you what, snowfall forecasting is not for the faint of heart. All right, Dallas-Fort Worth, again, some of your local models here are going anywhere from 3 to 4 to 5 inches of snow in the latest output. If you look at just the GFS and the NAM. If you look at the SREF we talked about down here in Dallas, it's averaging out to about close to just 2 inches. So it's got a lot of members up around the 2-inch mark. There's some around 3 and 4 clustered, so it's not bad. Let's see, let's go to the Super Ensemble Plume. Same idea down here in Dallas, around about 2 inches, 2.5 to 3 clustered in that area for an average. If you do look at the winter storm severity index, in other words, where is the trouble spot going to be, where you might have extreme impacts or major impacts, and that's mostly dealing with roadways and obviously maybe some infrastructure issues or maybe some power outages, something like that. And it does kind of favor in this region of Texas and also into far northern Louisiana and a good chunk of Arkansas. Now, this is a big caveat down here along I-20 because there's a lot of stuff here that could go wrong with temperatures getting too warm above freezing, and then you'll have to cut the edge off of all of this and just focus it in just to the north of that boundary. But regardless, that's where it's looking. If you look at the probability index of winter storm, For a moderate winter storm, you're in the red here, which is in the 70 to 80% probability, which is pretty good for again, that's a moderate storm. In a moderate meaning moderate impacts, expect disruptions to daily life, hazardous driving conditions, extra caution while driving, closures and disruptions to infrastructure will occur. Now, if you go to, just to give you an example how this breaks down, if you go to a minor, all right, so here's of a minor storm. You see how the probability just went up off the chart, so it's up basically at 100%. If we go to a major storm, all right, if you go to major storm, that's major impacts, major considerable disruptions to daily life, dangerous or impossible driving conditions, avoid travel if possible, and widespread closures or disruptions to infrastructure. And you can see where that is located. It kind of focuses here across the eastern third of Oklahoma on into a good chunk of Arkansas, but the probability of it is only hanging around about 50% down to around 20%. So you can see how that dropped off quite a bit in the intensity scale. So kind of give you an idea how you can try to weigh something when you're talking about probabilities and statistics. The guidance on this one for at least 2 inches of snow over a large area here is at a very high probability in the 70+% range in this region from Arkansas, but it does trail off a little bit by the time you get to the southern Oklahoma, northern Texas, and about 50%. So at least there's going to get some snow. Now we're talking about 4 inches of snow. It probably drops off quite a bit in this area, but keeps up substantial east of there. And if you're talking about 8 inches or more of snow, probability is down to around 1 to 5%, but it does highlight the sweet spot we've been talking about in the model data. And so obviously this is, if it does happen, then what do you say to a probability of 1 to 5%? If at the end of the day it was 100% probability that it actually happened, but the forecast model data and the human interaction was at 1 to 5%, there's a big disconnect, right? that's called confidence. All right, let's take a look at your extended outlook here when it comes to temperatures. Let's put this up here. Oklahoma City, again, we're going to be holding into the 30s here for the next few days through Friday. And then we'll be back into the 40s, looks like, over the weekend for Saturday, Sunday, Monday. But every time I show you this, the temperatures are up and they're down, they're up and they're down, or then they're flat. So they're all over the place because the chaotic weather pattern. I can just tell you overall it's cold, and we're going to have surprise intrusions of Arctic air that comes in here and messes up your day. And then there'll be days where, hey, it wasn't so bad today. You know, the winds weren't there. We actually got into the 50s and had some sunshine. And we actually got above freezing, like this day, for example. Maybe that'll actually happen. We won't even be freezing that day. But anyway, so that's some information for you as well. And then finally, for you geeks, weather lovers, and you want to see some really hardcore stuff, and you want to say, okay, tell me about this whole weather profile business down in Dallas. Let's look at the HER, and we'll look at the NAM for 2 examples, I think, what we'll do. All right, so again, this is, remember, red is temperature, green is dew point. This is looking up into the atmosphere, okay, from surface where we live, all the way up as we go different height. And what we want to look for is to see when we saturate. So we'll keep going in time. And we start to saturate where? Right there. We just passed it. So we went from here, where it's still relatively dry. Okay, too much depression in there. And then we went here at the next hour. And now we've saturated in the mid-levels. Everything's touching. And we're still a little dry down here. So what do? You get ice pellets. So in other words, sleet. That's your initial onset of precipitation. And this particular map says 8 a.m., again for Dallas on Thursday. And then you can see, though, as that moisture falls down, it starts to moisten up the lower levels, and you change over to snow. All right, so the HER goes, let's get you some snow in there, Big D. All right, now, if you notice, this is the other thing. This is my freezing line in the atmosphere that goes up like this. On this particular chart, it's called a SQT, but the point is we have to look at it at a way that we can interpret the data better, and so we can understand it, and so that's how it's drawn up and done. And in this particular case, all you care about is where are these lines in relation to this big line, right? If they're west of the line, you got all snow. If it nudges east of the line, that's when things get hairy. So let's see what happens. So that was at 10 o'clock in the morning. There's 11. Look at it touching the line. So this is where I have to tell you, the models cannot tell you whether or not this will actually happen. This could easily be here, or it could be here, but they will never know exactly, even the day of the event. They'll get close, but they will not be exact, which makes a forecast when it's sitting right on the line very difficult, because 0.1 degrees can hose you. So, and when you don't have the fidelity to get 0.1 degrees, it is a guessing game. Anyway, so here is a look at noon. And you see what happened? We just crossed over the line, and when that did, the model went out to ice pellets. So when I told you yesterday, I could easily see a lot of mixture of a sleet and snow mix, which would reduce snowfall totals overall. That's an example. And then when I showed you the SREF model, where it had a lot more warm air kind of sneaking in here, that would change it over into all rain before it had a chance to refreeze. That's trying to show up in this data as well. So again, it might be a mixed bag of precipitation down there in Dallas. You go to different precipitation types. In other words, 1 minute you got snow, 1 minute you got some sleet, 1 minute you got a little bit of rain mixed in. Anyway, so there's now at 4 o'clock, it went right back over to all cold, so it's got all snow, and it looks like it stays probably snow for the rest of the event. So if you're looking at snowfall total through just the evening hours, for example, it says 2 inches of snow down here in Dallas-Fort Worth, and if I take the snow off, what does it do for, about a couple of tenths probably of kind of a rain-sleet mixture within that in addition. But as far as Omega is concerned, these are the red circles. You do have some pretty decent lift at the lower levels and spots of decent lift in the snow growth zone. Not as good as it was in yesterday's data, which is why the models kind of backed off in general terms over the snowfall totals, because it's not juxtaposing everything that we showed you last night. It's typical. That upper level pattern, if it changes any or just shifts, that changes the whole thing. All right, so let's go to the NAM. Same idea. Let's see what it does, because I believe it was quite a bit different. So let's see. Here is 9 o'clock in the morning on Thursday. It's, again, starting off a little bit of a light freezing rain signature with this. All right, and let's go to 10 o'clock. Ice pellets, 11, ice pellets, 12, rain. And then back to ice pellets, rain, 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 snow. Interesting, because I wouldn't go snow with that. Snow there. Rain, 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 snow, 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 snow. All right. Really loud plane overhead. All right, so let's see here. It has a mixture of about half an inch worth of a very cold rain with a little sleet mixed in. Now that's wasted precipitation, by the way, because that could, at a 10-to-1 ratio, for example, just to use that as an average, that would be 5 inches of snow. So in other words, you've just wasted 5 inches of snow on a half inch of rain. That is boring. All right, what it does for snow, accumulation-wise, for this particular model, really? That's all it gives you? A half inch of snow? That's terrible. That is so terrible. All right, anyway, so that's kind of an example how that works. Again, if you're curious about Tulsa and Oklahoma City, we looked at data earlier, same kind of idea. I still like 2 to 3 inches overall. I'm sure some might get a little less, 1 inch, but most of us, I think, 2 to 3. The way it looks in the data, unless it changes, which we'll have to look at tomorrow and see if that's the case, but that's what I got here for you. So that was just some, again, some of the backdoor insider stuff that we look at here as a meteorologist. We're looking at weather data to figure out what in the world's going to happen. What does that crystal ball show you? And this is where the jokes come in and say, you guys can, be, half the time be right and still get paid. I'm like, yeah, we can. That's the reason why. But hey, that's it. You lose your hair over this stuff. Trying to be 100% accurate, given all that. Good luck. But it's fun. It's challenging. So what I would do at this particular case, when I see this stuff, I look for trends, right, to see what's new or different than the day before. Otherwise, you use kind of a persistence type forecast. In other words, keep what you had yesterday into today unless you see a reason to change it, right? So we call that persistence. And believe it or not, statistically wise, persistence usually wins out a lot more than it does for a dramatic change. So everything's kind of a slow nudge in a corrective endeavor until at some point the data screams, hey dummy, it's not going to happen. And at that point in time, either you go down with the ship or you make your last minute change and you're the laughing stock. Either way, because one, you either go down with the ship and you're wrong and you're on your face, or two, you get all that hyped up, everybody all excited just to pull it back and go, just kidding, it ain't going to happen. And everybody's like, what? For 4 days you told me it's going to snow and now you're telling me it's a cold rain at 33 degrees? See what I'm saying? So you can't win. You really can't. Now, in my case, easier call for Oklahoma. because our temperature profile is colder, I don't see any reason how that would change. I'm still thinking light wintry mix Thursday morning. Otherwise, it should be all snow. For North Texas, Dallas, Fort Worth, etc. I'm still thinking it's a mixed bag of everything, which means everything's lower on the totals when it comes to snow. I still think potential is there for 5 inches. If things work out well, maybe 6, If they don't work out well, you're looking more on the lower end, of the 2 inches maybe. 1 to 2 could even be, especially the south side of town. So I still think you'll get some snow. It's just, how much. And then the other problem is a melting. Let's say, for example, that I'm 100% right. Let's say it's 1 to 2 inches of snow on the south side. Maybe it's 5 inches on the north side, plain on. There's a big gradient and that kind of a deal. But if it's 33, 34 degrees and it's melting, about as fast as it's falling, how do you measure that? And that's another problem with winter weather forecasting. Because if it falls 5 inches from the sky, but you can't measure 5 inches on a ruler, what are you going to say it snowed? You're going to look at that ruler, and if it says a ½ inch, you're going to say it snowed ½ inch. Now, this is where you have to use your logic and go, if it snowed for 12 hours from noon on, let's just say from the morning on Thursday, let's say it was a 12-hour from morning on Thursday into the evening hours. So from, say, 7 a.m. to 7 p.m., just as an example. And it snowed that whole time. And you only measured ½ inch. Now, do you really think it only snowed ½ inch? I hope not. If you do think that, God help you. Because obviously it meant there was a lot of melting. And that stinks because as a forecaster side, we're trying to not only tell you when, where, how much, and what form it's going to be in. Then you have to accommodate, well, how much is going to melt? And that's another wild card that there's a big guessing game on that as well. So it's a nightmare too. Yeah, we have some model guidance on some of that, and even that's not that great. So unfortunately, snow, like I said, is very difficult. So I don't like to give snowfall totals prior to 48 hours out because things can change too much on that. And even now, we're Tuesday evening, so with most of the event happening during the day Thursday, and then still kind of continuing into Thursday evening, we're right at that 48-hour mark already for this particular measuring point of it. So that's what I got here for you on the breakdown of what I think, and looking at the data is a best good guess at this point in time. So tomorrow, what I'll look for to see if anything changes trend-wise, I will look to see if the Canadian and the European model back off and go, okay, we're just kidding. We're not doing a foot of snow anymore. I'll look for that. And then I'll look to see if the other models settle down on placement and if they kind of hold their better average, the whole 5, 6, 7 inches of snow in northern Texas, southeast Oklahoma, which is still a good snow. Don't get me wrong, that's a great snow. You don't have to have a foot of snow around here to have a good snow. So you can have 1 inch of snow in Dallas and be a good snow. But anyway, all right, that's it for me. I get out of here because it is. I still got things to do, and we all got to sleep and go to work tomorrow. So you guys have a great rest of your evening. Again, thanks for watching. Make sure you download my free weather app, AT's Weather to Go. It is free on Apple and Google Play. You can track the storm system, get your local forecast and your temperatures, all that kind of stuff. It gives you access to my website, which is AaronTuttleWeather.com. Gives you all kinds of stuff there. Road conditions, road closings, travel. It's got all that on there. So it's very helpful this time of the year. Let me think. What else? Oh, if you're in a situation where your heat hasn't been working too well, and you're like, I got a problem. I got the heat cranking, and I'm not really getting much heat out in my house, and I need some help with that. So on my website, you can check it out too, but you can go to my sponsor tab, and these are sponsors that support me here at AT's Weather. And Pronto Heating and Air will hook you up. Great team. They got great reviews on Google. They're going to hook you up and get your heat going again. And if you're worried about power outages and you don't have a means, to keep the lights on, there's a couple options for you. You can check out Solar Power, and you can get your whole system installed and run on a battery. They can give you a Tesla battery. They can give you another battery bank. And then you can also run on a generator. So Nathan Snyder Electric, they have great service on generators, and they're really not that expensive. I was surprised. I always thought generators would be a lot more expensive, and they're really not. And they're, in some cases, they're cheaper than doing the lithium-ion type generators. So it's just up to you on your preference as far as what you can afford. And then if you do have a situation where you run into some travel spots on traffic and you get in the fender bender, or maybe you need some better coverage in anticipation, check out 405 Insurance Advisors. I have my insurance through them for my car, home, and they're great rates. They're great people. So Leah and Jason will hook you up there. And if you need roof, Ferguson Roof Systems. I've been with Ferguson for years, and he came out and did my roof from the hailstorm recently. Did a great job. We detailed the whole thing and had a great time. And I got to learn a lot about the roofing business firsthand. Got to ask a lot of questions. That was neat. There was an interview I did with him a few years ago. Just a lot of the basic questions. And just recently, I had my friend Karen sign up. So she runs Barbalace Aesthetics down into Norman. She's got 5-star reviews of making you beautiful. So if you check it out, if you want to get some work done, some fun stuff, cosmetic stuff, check her out. Again, this is all on AaronTuttleWeather.com on my sponsor tab. You go up here to About AT, on the news section, and just hit sponsor highlight. And that'll give you all the information. And if you want to go over here to the weather data tab and you want to scroll on down to multi-state road conditions, you can do that, and you can scroll down. You get the soil temperatures here for Oklahoma and the snow routes, and you get the road conditions, and then you also have surrounding states. So some of this, whenever you do click on it, you'll need to update whatever comes up on the screen, because obviously it'll change for your browser. There's Texas road conditions. I even got New Mexico on there, for Arkansas, and some others. So anyways, that'll get you going as well. That's it for me. You guys have a great rest of your night. Again, thanks for tuning in on all the social media platforms, and we'll see you on the next broadcast. Take care, everybody.